Integration by parts. So we want to talk about this in a very easy way. We respect this word, LIATE. You know, when you're integrating by parts, you have the integral of the two functions u multiplied by dv. These are functions. And you want to keep u and multiplied by v minus, you will have to integrate v that is being multiplied by du. This means your integral, your question will be a product in the first place. A product of two functions. One that you will decide to name u, and the other one you will name dv. The one that you will name u, you will differentiate it to get du. The one that you will name dv, you will integrate it to get v. And you use v in this way. You use du in this way. So where we see this, it means we have to integrate. So you integrate, and in your solution, you integrate again for you to have the final answer. So how do we appreciate the word LIATE? This is about the combination. Since this is a product of two functions, it means the functions will be from these two categories. That is, one, you either have the logarithms or trig inverse or algebra or the trig itself or exponential functions. So every time I have a combination of two functions, starting from the left, your left is what is going to be your u, and then your right is what is going to be your dv. So if we have combinations, one, the integral of log multiplied by inverse, then you let u be the log and dv be the inverse. Okay, if I have the integral of the inverse multiplied by the algebra, then I will let u be the inverse and dv be the algebra. So any combination that you have, you check the order. You may not have this combination here because both of them are very hard to integrate. But you expect to have inverse multiplied by the algebra or the log multiplied by the trig, the log multiplied by the algebra, the trig multiplied by the exponential, or the log multiplied by the exponential. Either way, your left is always your du. I mean, it's always your u. And your right is always your dv. Let's go into examples so you can appreciate this. So saying these are initials. That mean you are likely to have the combinations of logs, of trig, algebra, trig inverse, algebra, trig, then exponentials. Starting from your left will always be your u, as you have those combinations. Now let me explain using an example, okay? Let me put an example here so you can enjoy this. Evaluate 1, the integral of x squared ln x dx. What do we have? We have a product of two functions. What functions? X squared is what we are referring to as algebra. This is what we are referring to as log. So in the LIATE, we have L and A. The left is our U. So here, we'll let U be equal to ln x. That's our left. Not the left of the product, but the left of the word LIATE. The product is algebra multiplied by ln, but you can write it. Yeah, it's the first page. And then your dv is going to be x squared, dx. So we have broken our product into two functions. The ln part has been called u, and the x squared dx part has been called dv. Then we differentiate u. The derivative of ln is 1 over x. Then we integrate dv. To integrate, we are adding, so we have x3 over 3. So here I have dx. Excuse. So now we'll say the integral of x squared ln x dx is equal to uv, u multiplied by v, which will be x power 3 over 3 multiplied by ln x, which is our u, minus the integral of v, x to the power 3 divided by 3 multiplied by du, 1 over x dx. The formula is you need u to be multiplied by v, and then subtract v multiplied by du.
Sorry, sir. I was late. Is that trick helping us to be choosing the right U or?
Yeah, it's helping us to be choosing the easy u and the easy dv.
Oh, okay. So whenever I have those combinations is to follow that.
Yeah, you check from left, your left of that combination. Your left is your u and your right is your dv.
So it's to remember that.
Yeah, it's to remember. It's very easy. Okay. Then now we have to integrate this one. So we see x into x3, we just subtract a 1 from the power. So we're going to have x to the power 3 over 3 ln x minus, I can write 1 over 3 outside so that I remain with x squared now, dx. Then we integrate x squared. What we get? x3 over 3 ln x minus x to the power 3 over 3 times 3, 9, and then plus 6. If you had tried, you pretend that you don't know anything in the exam, and you let you d ln x. I mean, you let dv. You let dv d ln x and u bx squared. When you try to move a bit, for you to integrate dv, for you to integrate ln, you will need a by parts. That is the first line. So if for you to integrate ln, you will need a by parts. And then you will see that things are not easy, Can one clear without knowing integration? It's the first slide. Can you clear without knowing integration? We want you to know the whole mathematics for this year so that you become good doctors. Don't be a passion enough. We want to be safe in your hands. Please, for the sake of our health, may you know integration. This was example 1.
Sir,
Hello.
is there any harm? I was trying to analyze this. Is there any harm if on the beginning I put like v then du, then at the end I put u dv? Is there any harm if I make that slight mistake to exchange those things?
You put v du and then you put
like
u dv.
Yes, on the left side, instead of putting the integral of u dv, there, I put v du.
And then here you put
then there u dv.
You'll be doing it.
Or it's just the formula. That's the way it's supposed to be. No another way.
Yeah,
around.
this is the formula. This one. This one. It's not a shortcut way of doing things. It is the formula.
Okay.
And in first year, all we do is to use the formula the way they are. Unfortunately.
Thank you.
Okay. Let's do another example. Let's see again. I take you somewhere, not far, but near. The integral of x squared tan inverse of x dx. That means the integral of x squared tan inverse of x dx. How do you integrate this question? So you let, if we go back to the word, you see that we have inverse of trig multiplied by the algebra. The algebra, the x squared. So it means we will let our u to be the inverse and our dv to be the algebra. And then we differentiate u. The derivative of tan inverse is 1 over 1 plus x squared. The integral of dv of x squared, this v, is x to the power 3 over 3.
Sir.
Hello. Hello.
I wanted to find out if it's the same thing of writing 1 over x squared plus 1 as the derivative of tan inverse.
1 over 1 over x squared plus
1 over x squared plus 1 over x squared plus 1.
yeah, it's the same.
Is it the same as the one that you've just
Mhm.
written there?
It's the same thing. That's plus.
All right.
Mhm. Okay.
So I'm a bit lost on how you got 1 over 1 plus x squared.
The derivative of tan inverse.
Yes.
We didn't drive it, we just put it boom. Yeah. We have to drive it. No, we don't have to drive it. You just put it there. Like this should be coming. I don't know where it will be coming from. Like maybe I've studied enough and you know it, and you just drop it here. But I can remind you of how we get it. If you have a function that is y is equal to tan inverse of x, and you want to differentiate it, you would write it as tan y is equal to x, and then use implicit to differentiate. The derivative of tan is of course x squared. Then you keep y. When you differentiate y, you get 1. Because you've differentiated y, you multiply by dy dx. Differentiate x, you get 1. So for dy dx, you have 1 over 6 squared y. Well, then you're talking of tan y is equal to x. So if we go to the triangles and place y somewhere here, this is 90. We know tan is opposite over adjacent. So if you had to find the hypotenuse, that will be 1 plus x squared square root. So if we had to get sec, we know sec is the same thing as 1 over cos squared y. So this is the same thing as just cos y, cos squared y. But what is cos y? Cos is adjacent over hypotenuse. But because it's squared, we also square it. So it turns out to be 1 over 1 plus x squared. And that's how we're able to just drop the derivative of tan inverse there. So now we know that the integral of u dv is uv minus the integral of v du. That is, what is our uv? We'll start with our v, which is x3 over 3, multiplied by our u, which is tan inverse of x, minus the integral of v, x3 over 3, multiplied by 1 over 1 plus x squared. There's always a dx here, so I have a dx here. I reassemble. I'll get this over 3 tan inverse of x minus 1 over 3 x3 over 1 plus x squared dx. Is it by parts again? Or it's what? Every time I have a denominator whose power is rather than the numerator, I can't use substitution. So what I do is I introduce long division. So I divide x squared plus 1 into x power 3. X squared into x power 3, you get x, and then you multiply, you have x3 plus x. When we subtract, we get negative x. So that we can write this guy, this x3 over 1 plus x squared as x, 1 on top, plus negative x over x squared plus 1. So here, this integral here, this one, we can do it from here. We say this guy is actually integral of x up plus minus x over x squared plus 1 dx. The integral of x, we get x squared over 2 minus this one here. We use substitution now. If we let u dx squared plus 1, then du is going to be 2x dx. So all we need is to solve for dx. So we divide by 2x by 2x. So we have dx is equal to du over 2x. Then we bring it here and have a nice integral now, which is the integral of what? The integral of x over u, where is the x? We put du over 2x. So you see, this x and this one cancels. Then we remain with x squared over 2 minus then half, then the integral of du over u. Every time you have du over u, you know where to run to, is it? You run to ln. So we have minus half ln u, but u is 1 plus x squared. So we get this integral. So we get this integral here. This integral. Substitute it. So now we have x to the power 3 over 3 tan inverse of x minus 1 over 3 open x squared over 2 minus 1 over 2 ln 1 plus x squared plus c. Okay, we can do the expansion a bit. We'll have x3 over 3 tan inverse of x minus x squared over 6 plus ln 1 plus x squared over 6 again, and then plus c. This is the integral. Hope the integral is okay.
Sir, you have integrated any index or you have differentiated in G2 profile?
We've differentiated.
Okay, sir, thank you.
Yeah, don't you know the integral for tan inverse? Memory. One was speaking down over the handle. We'll find the derivative of tan inverse. I'm not okay. Don't worry. We'll be okay soon. No, the tan inverse thing has to go through the triangle. if you have to find it. That tan inverse is like this,
Sir.
the second function, yes? Hello?
So I'm not clear on over. Are you getting me?
Yes.
So are you getting me? Yes, the
getting
integral over tan inverse is
No, I'm not getting it. And please don't say the integral of tan inverse, the derivative of tan inverse.
over one plus as when you differentiate. So they only listen to that, then do you? Yes, you're cutting.
I can't unable. I was unable to get you.
So I can't. I didn't get anything. You're cutting.
No, I haven't said anything. I was hearing from you. You were cutting.
Oh, I'm the one who was cut. Yes, I was asking. The other. Let me say the identity for tan inverse. If the integral for tan inverse, is it not one over what you've written there on? It's
Not
a
the
derivative.
not the integral, the derivative
Okay.
of tan inverse is 1 over 1 plus x squared. Where does it come from? We've derived it here. This is what we're doing.
Okay. Okay.
So be assured that if you are asked to differentiate tan inverse, you must go through the triangle. Tan inverse is like the second function on the calculator. And you know, for you to use a second function, initially you must have a tan y is equal to x. Then you lift it if you want to get the value of y. Then now we differentiate tan, you get x squared. There is y inside. So you keep it and then differentiate y, you get 1. But every time you differentiate y, you multiply by dy dx. That's why you have multiplied by dy dx. Then you differentiate x, you get 1. Then you solve for dy dx. You have 1 over 6 squared y. But the question has x as a variable. So you have to solve for 6 squared y and leave it in x form. That's why we have to use the triangle.
Okay. Thank you.
Right. For dv, you integrate. For u, you differentiate. So you have to differentiate u and integrate dv. So this is the basic. Once you're able to understand that any combination I have, I respect that pattern in what you pick, then you'll be done. So you've seen here we had algebra versus lim. Here we had inverse versus algebra. Any questions? So as for sine inverse and cos inverse, you must know them. Questions?
No questions.
Okay. The inverse for tan. What is tan inverse? What is sine inverse? If you are given sine inverse, you want to know the derivative. So if y is sine inverse of x, again you say sine y is equal to x, which you know on the triangle that if this is y, you have sine is opposite of hypotenuse. So you know this is 1 minus x squared. And then you square it. And then you do sine y is equal to x. What does that mean? You differentiate sine, you get cos y, and then differentiate y, you get dy dx. Differentiate x, you get 1. So you have dy dx is equal to 1 over cos y. What is cos y? Cos y is hypotenuse. No, cos y is adjacent to 1 minus x squared over hypotenuse, which is 1. So this becomes the thingy for sine inverse. If we had cos inverse, you have cos y is equal to x. Of course, for cos, the triangle will change a bit. For cos is adjacent over that. So this is going to be 1 minus x squared. And then you differentiate, you get negative sine y. Dy dx is equal to 1. So that dy dx is equal to 1 over negative sine y. Then you have negative 1 over what is sine y? Sine y is opposite over hypotenuse, which is 1. So for sine inverse, for cos inverse is negative 1 over that. And for sine inverse is positive. But if we are dealing with sine inverse of, say, g as a function, then we would say dy dx is equal to derivative of g over the square root of 1 minus g of x squared. If it was y is equal to cos inverse of g of x, then we would say dy dx is equal to g prime of x over the square root of 1 minus g of x squared, like that. An example, if I put y is equal to sine inverse of x plus x squared, then using the formula, dy dx is going to be, I differentiate this, I get 1 plus 2x, and then divide by the square root of 1 minus x plus x squared squared. That's a derivative. So I hope you understand this